Hi everyone! We've gotten a lot of questions about our new lineup of fur motors and what makes them different from each other and how they're different from the obsolete PSC motor. So I had our engineers put together a pretty cool display to show you just how our motors work. So you see behind me we've got 4 furnaces with our 4 different motors. The PSC motor that's now obsolete post-fur, the fixed speeds constant torque motor, our 5-speed ECM, the variable speed constant torque motor, our mid-tier motor, and finally the variable speed constant airflow ECM, our deluxe top-of-the-line motor. So we've got all these running at about 0.1 static, and as you can see here, we've got some watt meters that are showing the energy usage of these motors. So as you can see, our PSC motor is pulling over 400 watts, really using a lot of electricity, compared to our FCT, which is more around 210, 220, the VCT motor in the 232 range, and our VCA motor, again, in that 220, 245 range, using significantly less electricity than the PSC motor. And that right there is why the fur regulation exists. The Department of Energy wanted to make our gas furnace motors more efficient, and the ECM motor is how we're doing that. So let's take a look at what happens when my engineer restricts the static in the system. So right now he's kind of closed up the opening and we're at about 1 inch of static. The motors are struggling. You can see we've already lost some of our airflow indicators. The FCT and VCT are losing airflow, but the VCA motor, the constant airflow motor, is going strong. The PSC motor has also lost a lot of its airflow. They're all still pulling watts, but they're not able to meet those airflow needs of the system. However, the VCA, even at 1 inch of static, is still going strong. Its watt usage has increased, but it's still able to meet the demands of the system and provide that constant airflow.